Let's take a look at the molecular geometry for CH3 minus. This is the methyl anion. So the first thing we want to do when we're looking at molecular geometry, we need a valid Lewis structure. So this is the Lewis structure for CH3 minus. If we count the things up bonded to this central carbon atom here, the steric number is what we're looking for. We have 1, 2, 3 atoms and then one lone pair. So we have 1, 2, 3, 4 things, steric number of 4, and one of those is the lone pair here. So we go down and over, and we have trigonal pyramidal is the molecular geometry for CH3 minus. The ideal bond angle would be 109.5, but the lone pair here is more repulsive than these atoms, so it would push them down, make this a little bit less. Let's visualize the molecular geometry here for CH3 minus. So the purple, that'll be our central carbon atom. We're going to add 3 hydrogens, single bonded, 1, 2, 3. And you can see they all spread out. We're ending up right now with a trigonal planar molecular geometry. But we still have that lone pair. So we add the lone pair, and you can see it forces everything down. We end up with a trigonal pyramidal molecular geometry. The ideal bond angle, 109.5. But again, this lone pair here is more repulsive than these atoms, so it's going to push them down and force them closer together. That'll give us a bond angle less than 109.5. Back to our Lewis structure. We could also use the AXE notation to figure out the molecular geometry here for CH3 minus. A is the central atom, that's the carbon. X, that's the number of atoms bonded. We have these 3 hydrogen atoms here bonded. And then E, that's the number of lone pairs. We just have 1. So we write E. Sometimes people write 1. You don't really have to. If you look up AX3E, you're going to find out it's trigonal pyramidal, just like we found before. This is Dr. B with the molecular geometry and bond angles here for CH3 minus. Thanks for watching.